In this video, we are going to learn how to solve systems of linear equations using the elimination method when there's either no solutions or an identity, infinite solutions. Let's dive into it. So this says solve using elimination. Even if you're not told to solve using elimination, we see that we have variables on one side of the equation. So both variables on one side of the equation indicates use elimination. Okay, so if you haven't already watched the earlier videos on how to solve with elimination, I suggest you do that because I'm jumping into this assuming you have. So let's roll. So I want to eliminate variables here, and I notice that the x's can be the same exact, coefficient values. You could have a 2 here and a 2 here if we multiply this x by 2. So let's do that. So we can't just multiply the 1x by 2. You have to change the entire equation by a factor of 2 to keep everything equal. And so now from here, I get 2x plus 6y equals 18, just copying the top equation. You're basically a copy machine, so you're like, I am a copy machine, or maybe you're not. 2 times x is 2x, 2 times 3y is 6y, or y, and 2 times 9 is 18. And what you might notice here is, both equations are the same exact equation. So if you notice this, you might stop at this point and say, wait a second, each of these represent the same exact line. So it's the same line right on top of each other. And if you recall, we're trying to figure out how many places or in what place do these two lines intersect. Since they're the same line, they're going to intersect everywhere. So what that means is right away we know there's infinitely many solutions. That's it. You could be done at this point. Or you could write identity. Or you might say, you know what, let me go a little bit farther. So if you go a little farther, we want to eliminate the x's. We would have to subtract to do that. A positive 2x minus a positive 2x. So we have to subtract the bottom equation from the top. 2x minus 2x is 0. 6y minus 6y is 0. No variables. Ugh. 18 minus 18 is 0. So we get 0 equals 0, which is a true statement. So we've ended up now in a position where we have no variables and the equation is true no matter what value we would plug in for x and y. So what that means is there are infinitely many solutions. So infinitely many solutions. That's a weird way of writing it. You could also say that it is an identity. Oh yeah, peeps. Sweet. That's it. So when you end up with a true equation with no variables, it is an identity. And again, what I explained here, you could actually see a little bit earlier on that you have infinitely many solutions. Let's check out this. Well, right away, we see that we have the same exact coefficients here of the x's, -2 and -2. They're the same exact sign, so what I would have to do is subtract the bottom equation from the top equation. So let's do that. So if I subtract the bottom equation from the top equation, I get -2x minus a minus 2x is 0. 5y minus 5y is also 0, and 7 minus 12 is -5. Uh-oh. We get 0 plus 0 is 0 equals -5. But that's not true. 0 does not equal -5. And so what that means is, no matter what the x and y values are that we use, these two equations are never going to have lines that intersect. So there are no solutions, or you can just say no solution. That's it. So if you eliminate all the variables and you end up with an equation with just numbers that is untrue, that means that no matter what the x or y values are that we plug in, these two equations will never, ever intersect, right, if they're lines. So it's pretty sweet. Pretty sweet. So elimination method, it's really the same elimination method that you learned from the past, just interpreting the conclusions to see there's no solution or an identity. Now, let me say this. You shouldn't be looking to find that all solutions, right, to these equations are either no solution or identities. It's a result that when this happens, you get a number equals a number or a number doesn't equal a number. Now you know how to conclude correctly. See you next time.